Okay, I'm Louis Barta. So I guess my role with Farming Smarter is I kind of work a lot in the precision agriculture variable rate world. So I'm going to share a little bit about a research project we've been working on for the last 3 years, and we've got one more year of data to collect on it yet. So it's Canola Council funded research project, and it's a pretty big project. We're working in fields across the Prairie provinces. So far, we've collected data from 24 fields. There'll be another 8 or 9 in the next year. And the objectives of this project can be divided into really two components. There's some broad objectives where we're not just looking at fields and what happens in those fields, but we're looking at fields across the prairie. So what's the difference in how these fields behave in a variable rate context? And it's given us the opportunity to sort of look at some big data approaches. So we take the numbers from a bunch of different fields and sort of compare and contrast. But I'll start today with some of the specific objectives of this study. So really what we're looking at, what we're asking is, does variable rate technology work? And we're looking at this in a nitrogen management standpoint. And yeah, that's a question we're still asking. We're still trying to flesh out exactly how this works. So for this study, what we've done is for every field we've studied, we've gathered yield maps. So 3 to 5 years ideally, and divided the fields into zones, 3 zones. So low, medium, and high productivity. Then I've written a variable rate nitrogen prescription for each of these fields. So we've divided the fields into 4 plots. Each of those 4 plots gets a range of rates applied. So 0, 50, 150, 0, 50, 100, and 150% of recommended rates. So what's kind of fun about this study for me is we're out in the fields. It's field scale research. We're working with producers using their equipment. It's not always blue. We've got green and yellow too. So this slide I really like because it really shows the power of the tools of precision agriculture that we have. So I can sit in my office and I can draw a square. I can draw a polygon on my computer. I can load it up into a thumb drive, put it into a GPS monitor, drive out to the field, plop a flag in the field, and 3 months later and however many kilometers away, farmer will come in with his seeder, and that's how accurate it can be if everything's put together correctly. So this flag was put there ahead of time, the seeder went right beside it. So that really illustrates the power of the precision ag tools that we have. So then after seeding, we get to swathing, and again, it's kind of fun, you can see the treatment. So that red square there, that's our 0 nitrogen block. It's exactly where we plan it to be. It's kind of fun to be in the swath. You can see things are acting just the way you expect them to. And then after that, we gather all the yield data. So we take a few samples, we look at how things yield, and we look at the responses, the behavior of the crop. So for results, and this right here is what you all came out to the conference to see. A bunch of big question marks in the results section. So this study, we're only about halfway through it, so we're still kind of working through some of the data. And I'd love to take some time to tell you about some of the interesting things we found, some of the relationships between yield and nitrogen. But when it comes to variable rate technology, the honest truth is we don't really know what the answers are. For as good a job as we can do to understand variability, and we can do a really good job of that. We've got incredible data. We've got an incredible capacity to analyze that data, process that data, understand relationships between different factors. So whether it's elevation, a comprehensive terrain analysis, yield data, we understand variability. We know how fields behave, but we're not really able to take that next step to consistently and effectively manage that variability. So why is this? Why is it that we're struggling to make that next step? I think a big part of that is crop production is so dynamic. There's so many factors at play. So we can gather all the information, all the data, we can gather everything we want for this field. But if it rains 6 inches over the next 2 weeks, or we move 20 kilometers east, 10 kilometers north, the implications of that data completely change. The context of the information we've gathered, it changes. It's no longer applicable in the same way. So what do we do with this? I'll start by looking at some of the broad objectives of this research project. So this slide shows some of the results from the first year of the study. So we have 3 fields from Alberta in the red, 3 fields from Manitoba in the green, and then a field from Saskatchewan, so year 1 of the study. And what this graph is showing is it's showing the response of yield in each of the zones in each of the fields. So the top row is high yield, historic high yield based on our yield maps, and the bottom row is the low yield. So the shape of that curve is showing how crop yield responds to increasing rates of nitrogen. And the shape itself of that curve, that's telling us how the crop in that zone is behaving. So let's look at one of those curves. Let's look at the average zone for the first field in Alberta, and it has a particular shape. Now you'll notice that shape is uncannily similar to the shapes of the curves of the other two zones in that same field. And if you look at the field next to it, the second Alberta field, all 6 of those curves are remarkably similar. Now it just so happens that both of these fields are in quite close proximity to one another. In fact, you could probably stand in one and see the other. So if I take this curve that's highlighted in orange here, and I use it to predict behavior in the other zones in that same field, it's going to do a pretty good job. So what happens in one zone in one field can give me a pretty good idea what's going to happen in the other zones in that field. And it's also going to give me a pretty good idea what's going to happen, what that behavior is going to be in zones in a similar field. But if I take that zone and I try to apply it to a field in Manitoba or a field in Saskatchewan, it's not going to really effectively predict that behavior. So really what I'm getting at here is that variability between fields may be as significant as the variability within fields. So the information we find in one place may not be applicable to behavior that we might expect to see in another location. So this chart's a little dense, more than a little dense, but really what it's doing is it's quantifying that idea. Basically, all you need to draw away from this is that it's showing that the variability, the differences between fields is perhaps as significant as the differences within fields. So what do we do with this information? Well, over the last little while, there's been a growing appetite for field-scale research, field-scale trials. Seed companies have been doing this for a long time. So variety tests have been done in farmers' fields with their equipment, and we're building comparisons. The research world is starting to look in this direction. I think the Pulse Commission is looking at, I think they're working on a plot-to-field research program where they're investing in taking research from small plots and bringing them out into the field. But probably the biggest push is producers themselves. And the whole idea, I think, we do small plot research because we can control that variability. We know what's going to happen, and we know that the responses we see aren't due to any external factors. We control that variability. But what producers are saying, I think the idea is, that's great. That's great that we can see this response in a controlled environment. But show me that this works in the real world. Show me show me this in a field. But I don't think that's really the question that's being asked. I don't think anybody's asking to see it in a field. I think the question is, show me this works in my field. Show me that I can see this response in my unique circumstances. So let's do that. I'm going to take you through a hypothetical research trial. So we're going to do a field-scale research trial, 30 fields across the prairie provinces. We've got two treatments, treatment A and treatment B. It doesn't matter what they are. It might be variety, it might be fertility. So 30 fields across the prairies. Treatment A yields 45 bushels an acre. Treatment B yields 48. So what that means is if you took 100 fields across the prairies, you could expect to have a 3 bushel yield increase with treatment B. But what does that mean for my field? What does that mean for your field? We don't really know. Think back to that variability between fields, how information from one field doesn't always apply to another. It's really tough to take these average numbers and understand how that might apply to your specific field. So say we zoom in, say we look at Alberta. We're still dealing with the same issue. We've got, even if we looked at southern Alberta, we've got different properties in Lethbridge, Bow Island, in Mossley, anywhere. I mean, things change so much. We tend to, I think an average isn't a terribly powerful number. It's a good benchmark. It tells us what we might be able to expect, but it doesn't tell us what's going to happen on our field. We sort of have to dig in deeper, look at the variability within those averages to really be able to apply that information to our own circumstances. So let's zoom all the way in. Let's look at our field. let's put in a legitimate randomized and replicated trial. So now we know how crop's going to behave in our field under our circumstances. 48 bushels for treatment A, 50 for treatment B. So this is great. We know how our field behaves, but we don't necessarily know that it's going to behave the same next year. And when you think about it, we're still looking at averages. We're still taking all the yield from treatment A, putting it in a weigh wagon, and coming up with an average number. And same for treatment B. So how do we put this all together? How do we take the things we're good at? We've got these powerful tools of precision agriculture. We've got an incredible capacity to understand variability, to gather information about variability, and to understand the relationships between all these factors in our soil. So how do we put it together? Well, instead of studying 30 fields across the prairies, let's take one field and let's divide it into 30 sections, into 100 sections. Let's use the things we know, use the tools we have to study what happens in our field, and instead of working with averages, let's give those numbers some context. So maybe, for example, you have the same average yields, but you've got ranges attached to them. So rather than just saying 48 bushels an acre for treatment A, you've got a range of 46 to 50, whereas treatment B is 20 to 80. So if your break-even point, if you need to get 45 bushels an acre to break even, treatment A is a much less risky option. And there's a lot of other things we can do with this too. We can dig in and we can understand why the regions that produce low are producing low and why the regions that produce well are producing well. And that might not lead to variable management of that field, but that'll tell us a little bit about how to make decisions in the future for our particular field. So there's a scale. We've got the broad on this side, and that's the averages, the benchmarks, the ballpark numbers that give us a pretty good idea of what's going on, but may not apply to our field. And on the other end, we have the specific. That's, instead of 30 fields across the prairies, that's one field divided into 30 sections. And finding the sweet spot on that scale between the broad and the specific, finding that balance, that's the key to moving from deciding how to manage a field to deciding how to manage your field. So if we're going to keep moving in this direction of field scale research, and I really think we should, I think there's real potential there. We've got these tools, we've got this capacity to collect and manage and analyze data. So let's use this. Let's use this to make those numbers more than just averages. Let's dig in deeper and let's really understand specifically how to manage my field. Thank you.